Hi folks, it is our pleasure today to have Professor Ramesh Sitaraman from the University of Massachusetts at Amherst. Ramesh got his bachelor's at IIT Madras and his PhD at Princeton University. So, and he's been at UMass at Amherst since. And in general, he's been working on large-scale internet distributed systems, algorithms, architecture, energy efficiency, and economics. And in particular, he is a principal architect of the Akamai network, which is, as we know, carries a very large fraction of the content that the world consumes. And so he's going to tell us something about how video performance impacts viewer behavior. Let's welcome Professor Sitaraman.
Thank you, Srinivas. I'm really happy to be here. I'm going to be talking about a question that I've been sort of fascinated with for over a dozen years. And the question is, what is the relationship between performance of videos and how viewers interact with those videos? So I want you to step back a little and think about, video watching is a very common experience. We all watch online videos. I would like you to think about how you yourself have reacted to videos. So if you are trying to watch a video and it doesn't start up quickly, would you leave? Would you abandon? Or if it freezes in the middle, would you watch less? Or if it completely fails, you're trying to watch the video, it completely fails, would you go back to the same website to watch more videos, say sometime down the road? Now, most of you probably feel like this person here. You might feel very frustrated about the whole thing. And most of you would probably say, yeah, I mean, if it freezes a lot, I would probably watch less. But what I would like to do is answer these questions scientifically. I want to answer them scientifically, first of all, in a quantitative way, so that one can actually quantify how much video performance can cause how much change in viewer behavior. And I also want to answer these questions causally. What do I mean by causally? I want to really make sure that the video performance is what made you behave that way. For example, if I see a viewer watching less and quitting the video, there can be many reasons why that happens. I want to be reasonably sure that it's because of performance reasons. So this is really the topic of this talk. Now, how do you answer these questions in a causal and quantitative way? But let's think a little bit about why this is even important. Why even study this, right? Why study viewers and viewer behavior? Of course, as a very famous mountaineer said, we study it because it's there, and scientific curiosity is certainly one reason why we study it. But I would like to convince you that these questions are extremely important for other reasons too. Okay, and why is that? Why are these questions so important? Online videos are really the killer application of the internet. If you look at any statistics about videos, it is sometimes frightening and at the sometimes exhilarating as well. For example, 86% of people in the US have watched online videos. So practically everybody has watched online videos. Over half the internet traffic today, consumer traffic today, is videos. So already videos are very important.
Can I ask one question?
Yeah.
If you were to look at it as the percentage of the time we spend, what percentage of our internet time is spent watching video versus reading stuff or whatever?
I don't have a good answer to that, but I would guess that it would be a significant fraction. But I don't have a good answer to that. But the future actually looks even more. In the future, videos look even more important, because pretty much any statistic you'll see on videos show it increasing by 3 times or 4 times or 5 times over the next few years. And in fact, there is a projection out there which says that videos will be almost 86% of the consumer traffic on the internet. So clearly, videos are extremely important, and pretty much your media that you think of as television, all of these things are going onto the internet.
So, Ramesh, does this include Netflix traffic, the numbers you're quoting?
This is all in terms of traffic, yes.
No, but does this include Netflix traffic?
It includes Netflix traffic. It includes all traffic.
So what percentage is Netflix traffic?
I don't have a good statistic for that. I think it would be pretty high. This prediction is actually based on some work that Cisco did. The 86% prediction is actually based on some numbers from Cisco, who predict, by 2016, video will be a large part.
Mm-hmm.
So, but that projection is based on before Netflix took off. I think the number may be off a little bit.
It's a pretty, it's a pretty recent projection. I mean, the projection actually, or the projection was done, end of 2011 maybe.
3 years ago, roughly.
So yeah, I mean, and the projection obviously includes, the growth of video in general. But I think the high-level point is that videos are going to be a large fraction of the traffic. Now, one of the big questions that's out there is, how do you monetize videos? People are all, really, fascinated by online videos, but how do you monetize it? It's a very important question. So, if you talk to a video content provider, and by video content providers, I mean people who provide news, like ABC, NBC, people who provide movies like Netflix, sports, television channels, all of these people who have videos, they're actually thinking very hard how to actually make money out of it or even break even from these videos, because videos actually cost money to deliver to users, right? You need servers, you need bandwidth capacity, you need to spend energy doing it, in other words, power. So monetization is a very important question, and roughly there are 3 different ways out there that people are experimenting with. One is video ads, showing ads during the video, either before the video like a pre-roll, or in the video itself like a mid-roll or a post-roll after the video. People are trying out subscription-based services, obviously, where you subscribe and then you play, and they're trying things like pay-per-view, right? So that people are trying a lot of different ways in which you can actually monetize these videos, and this is actually very critical because you have to be able to monetize these videos for the online video ecosystem to evolve and grow. Okay, so it's a very important problem. If you think carefully, though, monetization seems to depend on one thing, and that one thing is viewer behavior. So, independent of what kind of monetization model you use, the main important thing is people who have videos have to figure out how to engage their audience and keep them watching more and more. And I'll talk about this in a minute. Whether you're in a subscription model or in an ad-based model, that's going to be important. So what do I mean by, making users watch more and more? I think there are 3 aspects to it. The first aspect is reducing abandonment. What do we mean by abandonment? When a user comes in to watch a video, you want to make sure that that person doesn't abandon and go away, okay? Even before the video starts playing. Second thing is what I would call engagement. Once a person starts to watch the video, you want them to watch longer. You want to engage the user and have them watch longer, and that's what we call engagement. And you want to enhance what we call repeat viewership, which is once a person has watched the video and say that person has left, you want that person to come back again, say maybe in a day, maybe in a week. So there are 3 key aspects that I'll focus on: abandonment, engagement, and repeat viewership. And all 3 of these are critical for video monetization, because if you think about it, if people don't abandon and are more engaged, that means they're watching more of your videos, and that means that you have more opportunities to show ads, for example, right? If they come back again more and more, then it means that the video provider has loyalty among the users, and the video provider can exploit that loyalty and use a subscription model, for example, expand the subscriber base. So whichever way you think of monetization, the point that I want to make is that these aspects of viewer behavior are the key. And to make online videos work in the real world, you have to understand viewer behavior. So this is a very big motivation for why I would like to study viewer behavior. Now, that really brings me to an important question. How do I influence viewer behavior? How do I make it better? For example, how do I make users abandon less? How do I make users engage more? How do I do that? It's an important thing. The first and obvious answer is, of course, get yourself better content, right? Video content is something that influences viewer behavior a lot. We know that. Video content, what do I mean by that? I mean things like the storyline of what is being watched, how it is picturized, how relevant is it. All the things, the content of the video that makes you watch is obviously important. This talk is not so much about the video content. In fact, I don't know that much about how to make movies or any other stuff. This is about a different thing that influences viewer behavior, and that thing is video performance. So this talk is really about not the content of the video, but how the video actually performs, how it's delivered. So what do I mean by video performance? I mean things like availability. If you click on the play button, does the video play? Or does it play? I mean things like fast startup time. So when you click on the video, does it start up quickly? I mean things like less rebuffering, which means as you play the video, is it freezing in the middle or not? Those are aspects of video performance. And the main punchline of this work is that we are able to show that video performance is the second factor, an important factor that can influence viewer behavior, and we are able to show that sort of in a scientific fashion. And this is the first time that anyone has been able to link these two things in a causal way. Okay. So let's be a little more precise. So I'll be talking about these aspects of video performance. Like I said, availability, which is does the video fail or not when you try to start it up? Startup delay, which is how much time does it take for a video to start up? And rebuffering is really the freezes that you see in the middle of a video. Obviously, less rebuffering, less startup delay, and more availability would hopefully make viewers watch more. And on the right side, I have all the viewer behavior metrics that I talked about. Abandonment, which is people abandoning even without seeing the video before it starts up. Engagement, which is basically how long do they watch the video. That's a good measure of how engaged they are. And repeat viewership is really about coming back after watching videos. How frequently do they come back? These are very important aspects. Obviously, I want to actually try and relate what's on the left to what's on the right. There are many combinations that are possible that you could study here. But we studied 3 of those combinations, which we think are the most important ones. And these are the 3, and I'll be talking about these more. The first question we asked is, how does availability impact repeat viewership? In other words, if a viewer tries to download something, a video, and the video fails, is that user less likely to come back again, say in a week, in 2 weeks? The second relationship that we wanted to study is the following. If I click on the video and it takes too long to start up, startup delay is too high, would people abandon the video? Would people say, forget it, I'm going away? And we wanted to study that phenomenon. And finally, we wanted to study rebuffering, which is the freezing that happens in the middle of the video. We wanted to see how that could affect the engagement of the viewer. For example, if a video freezes a lot, would the viewer watch less? And we wanted to study these things, as I said, not just anecdotally, but we wanted to study it scientifically. which to us means two things. One is we want it to be quantitatively precise, and second, we wanted it to be causal in the sense that we want to actually make sure that it is rebuffering that's causing people to watch less and not something else, like the content was boring so I watched less. We want to remove those kind of effects out of the picture, okay, and that's where the challenge comes. So this is what I'm going to be talking about over the next several minutes. But first, how do you study this? So hopefully by now I've convinced you that viewer behavior is important to study, and so the next natural question to ask is, how do you study something like this? And as you may have guessed, the first thing you need is lots of data, right? And the kind of data you need is data that relates viewer behavior and performance. So the data, whatever data you're collecting, should have aspects of the viewer's experience or performance that the viewer is experiencing, as well as what the viewer is doing. Is the viewer abandoning? Is the viewer watching? Is the viewer coming back later? All of these things should be in there. So even a few, I mean, I think I mentioned in the beginning that I've been thinking about this problem for a dozen years at least. But for most of those dozen years, the data really wasn't there. It's only over the last few years that we can even imagine collecting some data like this. And what really makes this type of data possible to get nowadays is that media players are now very customizable. So you can take a media player and drop a plugin into that player. And what that plugin does is it can observe what the viewer is doing. Is the viewer abandoning? Is the viewer rewinding, fast forwarding, watching, pausing, all of those things. All the behavioral aspects can be recorded. At the same time, you can also record the performance aspects. For example, how much time did the video fail or not? How much time did the video take to start up? How much time that the video rebuffers? All of these things can be recorded. And these plugins can record these things and transmit that information into a backend where this can be analyzed. So Akamai has a system for monitoring these type of things. It has a plugin that runs in, tens of millions of users around the world, and they can report back using what we call beacons, information of this sort. So you really need this type of information to be able to do this kind of work. Okay, and nowadays, the last 3 years or 4 years, I would say, it has been relatively easy to get this kind of information. Incorporating a plugin into the media player is technologically feasible. So what we did was we used data from this kind of a measurement platform, and we actually studied. This is probably one of the largest studies for tracking causal behavior of users. We actually studied a lot of a lot of users. We studied something like 6.7 million unique viewers who watched 23 million videos for 216 million minutes from across the world. So we collected data, a large set of data, and our goal was to really figure out this connection between viewer behavior and video performance. So it's not just, before I go on, it's not just the data that is important. The techniques are actually very important too. Like I said, we want to make quantitative and causal relationships. So we have to actually think very hard about what techniques to use.
What exactly was your beacon?
So a beacon.
Is it a browser plugin, or what is it specifically?
It's a plugin that runs. So the plugin itself runs within the media player, and it makes measurements from the media player. Measurements will include performance measurements as well as what the user is doing.
Mm-hmm.
And the beacon simply is, is a message that is sent from the media player into a backend. Say it's configurable. Say every 1 minute you send information on what is happening, right? And then the users who have the plugin, they send information into the backend. That piece of information that gets sent is called the beacon.
So is it just embedded in browsers, or is it also in things like set-top boxes?
It is actually, it is embedded in set-top boxes. It's also embedded, in just your browser player. So when a content provider builds that player, they can actually place a plugin in that player.
Okay, so you're getting the behavior of people not just watching from their computer, but watching on their TV as well.
Watching, it can be incorporated into into set-top boxes, into devices like mobile phones, and so on. And the Akamai version of this is very widely deployed because a lot of content providers use Akamai for their streaming services. Okay, now the techniques are actually important. So the most common technique that people use, if you look at computer science or engineering literature, is simple correlation, right? That's what people typically use. So here is a correlational. Suppose we want to see if video rebuffering causes viewers to watch less. Remember, I said this was one of the 3 things that we're looking at. Here is a simple thing you can do. You can just correlate the 2 things. You can put playtime, which is on the y-axis here. This is playtime. Playtime is a measure of engagement, right? People who play more, we say are more engaged by definition. And you can put the rebuffering on the x-axis. And it's pretty easy to see from the scatter plot which we got out of our data that they are inversely correlated, right? In fact, we can go into what correlation tools to use. I mean, I think rank correlation is a better way of dealing with things like this, and clearly it's inversely correlated. But here's the tricky thing. Just by this correlation, you can't quite say that rebuffering is causing people to watch less, right? And the reason is correlation and causality are something slightly different. Correlation between A and B means they're moving together, or moving, if they're inversely correlated, they're moving opposite to each other. But causality actually means something stronger. It means A causes B. And the reason why correlation and causality are not the same is there can be what we call confounding variables. There can be variables that cause both A and B. And so A and B could be correlated, but A is not causing B. Okay? And this is one of the difficulties we come up with in trying to analyze things like this. So let me talk a little bit about causality. I won't go, I mean, it's obviously a very deep subject. People have studied it for centuries. So I don't want to go, I'll just give you some basics here in terms of why you should think more carefully about causality. Here is a simple, well-known example of why causality and correlation may not be the same. If you take the ice cream sales in the US and the drowning deaths in the US and plot a graph, they'll be correlated, strongly correlated. Can we conclude that eating ice cream causes drowning? The thing is, there is a confounding variable, which is the summer weather. The summer weather causes ice cream sales to increase, and also drowning deaths to increase because people go swimming in the summer, right? So just a correlational plot between those 2 things is not sufficient. You need to say something more sophisticated. Okay. Here's a more subtle example. Someone about a dozen years ago studied the following. They took people with myopia who had short-sightedness later in life and went back and saw if their parents left the bedroom lights on. And they saw those 2, 3 things to be extremely correlated. People who had lights on while sleeping as children seemed to be correlated with people who had myopia later in life. In fact, they wrote a paper in Science that with this kind of correlation that lights actually cause myopia. But later, someone realized, looking carefully at the experiment, that there was one confounding factor that they are not considered sufficiently, and that is the parents' own myopia. The parents' myopia is transferred to the children through genetics. And at the same time, parents with myopia tend to leave the lights on because they can't see too well. They're more likely to leave the lights on in the dark. So the parent's myopia is a confounding variable that could cause both the lights being on and myopia later in life. And doing a better analysis with this confounding variable in place actually disproved whatever was proved earlier. I think most people now believe that there isn't a causal connection between lights, turning on lights and myopia. I just give these simple examples because I think people in most of the analysis you see are correlation based, and you always have to step back and think, is this truly causation? Okay. Let's come back to our example. So in our example, I showed you this plot here, which had engagement or playtime on the y-axis and rebuffering on the x-axis, and it looks very correlated. But I claim that this is not sufficient to conclude that the rebuffering caused the playtime to decrease. And the reason is there are possible confounding factors and threats. So consider the following threat. So consider the following situation. Let's say there are users who are better off, who are richer. Those users can afford better network connectivity, and so they tend to have less rebuffering. At the same time, they can also afford access to more interesting content, which could make them watch longer. So by looking a little bit more deeply, there can be a threat. I don't know if this is true or not, but this is a threat. You cannot ignore a threat which basically says that, you know what, richer users have better connectivity and also have more content to watch more. So these are the kind of tricky things that we want to actually capture in our analysis. And in all the analysis that we talk about, we always consider as confounding variables, connectivity of the user, the content, the actual content that's being watched. It's an important confounding variable because some content might be boring, some content might not be boring. So you can never compare two people across content. And we also look at the geography of the user because there are a lot of cultural traits that might actually lead to confounding. So these are three things that we always think of as confounding variables. So I'm still in the process of talking about techniques. So how do you really deal with confounding variables? The standard technique for dealing with problems like this was actually proposed by R.A. Fisher, who many consider the father of modern statistics. And the solution is what is called a randomized experiment. The notion of a randomized experiment is that you pick individuals. So this actually comes from social sciences and medical literature. So we tend to talk about things like treatment and control group or untreated users. So if you want to show that a treatment impacts a disease in some way, cures a disease, for example, the way randomized experiments work is that you take individuals and randomly assign treatment or placebo. So you pick people from the population and give one person treatment randomly, and the other person is untreated. Maybe they get a placebo, and then you compare the control group with the treated group. Okay, and this statistically will get rid of confounding variables because of the random selection. The confounding variables will be equally present in the treated group for large enough samples as the untreated group. And so this is the classical way with which people deal with confounding. But this way of dealing with confounding is actually not a viable method for us. So if you think about our situation, we are trying to show that video performance impacts viewer behavior. So our treatment is bad performance. So you want to compare people with bad performance with good performance, right? And we cannot really do a truly randomized experiment because we can't take individuals and randomly provide them bad performance, right? I mean, I wouldn't say you can't do that, but it's very difficult to do, right? It's operationally difficult to do. It may not be cost effective. It may not even be legal and ethical. So from our standpoint, that's actually a hard thing to do.
Question here.
Yeah.
So in the previous slide when you showed the plot, if you compare the same clip at different upload rate, then you'll be able to see the impact. You don't have to run experiments. Just by narrow down to specific clips of video, you can see the results.
Right. That's kind of what we are going to be doing. We're actually going to do something which we call a quasi-experiment, which actually tries to do something like a randomized experiment, but without controlling anything. Okay. So this is really what the technique for analysis called quasi-experiments, and the idea is somehow you need to isolate the impact of video performance and equalize all the other confounding factors like the content being boring, the geography of the user, and the device. Okay. So here's what we do. Remember that we have lots of data, right? This is where lots of data helps, right? What we do is intuitively very easy to understand. To sort of show that performance impacts behavior, what we do is we pick randomly pair up users, like this user on the left and this user on the right, who have the same values for the confounding factors. In other words, they're very identical. The only difference between them was that one was getting poor video performance and the other one was getting good video performance. And we construct a lot of these pairs, something like more than 100,000 pairs. And by following each pair and see what they do, you can either support the hypothesis, reject the hypothesis, or just be neutral. So the basic idea is that you pair up viewers who are identical, and the only difference between them is poor video performance. One person got poor video performance, the other one got good video performance. So they differ only on that axis, and then you see what they do, how they behave in the future. And if the behavior supports your hypothesis, then you can score it to the +1, and if it doesn't, then you score it to the -1. And by doing it for hundreds of thousands of viewers like that, you can actually get a fairly good understanding of whether there is a causal impact of performance and behavior. Okay, that's the basic idea. This basic idea is not a new idea, generally speaking, because quasi-experiments have been in existence for at least till the 19th century. So there's a classic case of a physician called Snow, who in London did a quasi-experiment to show that the water quality causes cholera. It's a very classic example. And more recently, more 20th century example, there was this study that showed that, I think it was Kruger who studied this phenomenon in the 1990s, who showed that schooling actually can lead to better salaries. I think people like us in universities would love that study. It actually, the way he showed it is interesting. He took twins and paired them up, and the only difference he found twins where the only difference between them was level of schooling, and then he tracked their salaries later in life. So that's a very good example of this. The novelty here, though, is that we are taking these ideas from medical and social sciences and applying it in the computer science context, in the network measurement context, and really we are the first to do that in this context. And I think these tools might be useful in other computer science contexts as well. All right, now let's actually go into the results. The first question I said was viewer engagement. Let's continue on that. So what we want to find out is, does rebuffering reduce the time that a viewer plays a video? And we saw this correlation chart before, and we said that we need more. We can't just, based on this correlation chart, conclude that people with rebuffering watch less. And so we set up a quasi-experiment. And here's how the quasi-experiment was. We paired up users, and these users come from the same geography. They're using the same connection type. For example, if someone is using a mobile device, the other one is using a mobile device too. If someone is using a desktop with fiber connectivity to the world, same with the other one. They're watching the same video, in fact, they're watching the same point within the video, and that's important because some points in the video can be boring and others could be interesting. And so we create all these pairs where the pairs are all very similar, okay? And I think we do something like 75,000 pairs, and we then score each pair by taking the difference in the play time between the untreated and the treated. So the untreated watched for 5 minutes and the treated watched for 2 minutes, then the score would be 3 minutes, right? Now, if our hypothesis is really true that rebuffering is going to cause smaller play times, then the treated should really be watching less, right? On average, okay? So we do the scoring, and we do this for lots and lots of pairs, and we can actually come up with the following result. When the treatment was 1% rebuffering, which means that the person whom we call treated got 1% rebuffering, and the other person got no rebuffering. What we found was the person who got no rebuffering watched 5% more, or put another way, the person who had the rebuffering watched 5% less. So a viewer experiencing rebuffering for 1%, our quasi-experiment results show watched 5% less of the video. And then we do that for other ranges of rebuffering as well. As the rebufferings get to be more and more often, people are watching less and less. So this is the kind of quantitative and causal kind of statement that's very useful, because it basically puts a value on performance. It basically says, you know what, a person who experiences this amount of rebuffering, the impact of that is going to be they're going to watch this much less. We also do some, I won't go too much into this, but we also do statistical significance. How significant are our results? And typically the way we do that, the simplest way we can do that is what is known as the sign test. The sign test simply says, what is the probability? Suppose you have an outcome which says 1% rebuffering gives you 5% less play time. What is the probability that it could have happened by random chance? Right? If there was no impact at all of rebuffering, you would expect, either of these to watch more or watch less with equal probability, right? If there's no impact at all, the person on the left or the person on the right could be watching with equal probability. So you get pluses as much as minuses. And we simply ask the question, what is the probability that this result could have been gotten just by chance? And that's typically called the p-value. And the p-values for these results are actually very small, which means they're highly statistically significant. And that's simply because we have a lot of viewers. Okay. Now let's actually switch to the next interesting topic, which is viewer abandonment. So here, what we would like to study is, how long will viewers really wait for video to start up? It's a very important question because it talks about viewer patience, right? So if you're building a system to start up to do this, when should you start up your videos? What should your goal be, right? So we looked at the data. I won't be going into the quasi-experiments for all of these. I just did that for the first one so that you get a sense of the technique. But you can actually read the paper to see the quasi-experiments for all of these different things. So we computed something called abandonment rate, which is the percentage of viewers who lose patience and abandon before a video starts up. And we plot that against the startup delay, which is on the x-axis. So the x-axis is the startup delay, and the y-axis is the abandonment rate. And as you can see, there's hardly any abandonment for the first 2 seconds, and then the abandonment rate starts to increase. And so this tells you something about viewer patience. So this is kind of what we call the 2-second rule, where people seem to be waiting for 2 seconds before they start abandoning, and about 5 seconds, a quarter of the people are gone, and about 10 seconds, half the people are gone. There's been a lot of social commentary since we published this work. There's been a lot of social commentary about these results, and some people believe that society is getting more impatient, and there's a lot of societal kinds of discussions going on over about these results. I won't really go into those too much. But it is interesting to ask 5 years from now, what will the 2-second rule be? And if people are getting more impatient, it would likely be smaller. So as I was actually investigating all of this, I got very interested in something called the psychology of queuing. I just learned that people have studied queuing in the physical world and the psychology behind it, and it's actually a big area of research within psychology departments. And there are a lot of fascinating things known about how people wait in the physical world. When do they get impatient, things like that. And I wanted to really find out if those things actually apply to the virtual world. It's a very interesting question, whether all of those physical things really also apply to the virtual world. So here is actually an interesting thing that I want to talk about. So people have found that time is actually very relative, psychologically speaking, in the physical world. So back in the 19th century, when the Transcontinental Railroad was first built, it connected the East Coast to the West Coast. And for the first time, people could travel from New York to San Francisco in 83 hours. People are really thrilled about this. People said, wow, this is just amazing. And they called it the Lightning Express, right? But now you look at it and say, that's really way too long, right? What has actually happened is our hardware is the same, but our expectations are different. And that's what I mean by time is relative. So we wanted to study if that kind of a phenomenon exists in the virtual world. So we asked the question, what if we took viewers and examined their patience levels? Suppose we took viewers who had good connectivity, like fiber connectivity, and we took viewers with broadband connectivity, cable, DSL, viewers with mobile, and looked at how patient each of those things were, each of those viewers were. And we found something very interesting. This is the abandonment rate, and this is the startup delay. And you can see that the mobile users are very patient. They're abandoning much less. Whereas the broadband users are abandoning much more quickly, and the fiber users even more quickly. And so we were actually able to also do a quasi-experiment to establish that people really get used to speed. The people who are on fiber are much less patient than people who are on broadband. And that's an important phenomenon to know. Here is another phenomenon that we wanted to test out. So here is a question that I ask. Waiting for 30 minutes for a plane ride or waiting for 30 minutes for a cab ride, which is more frustrating? And most people would say waiting for the cab ride is more frustrating. Part of that is expectation. You expect to wait less for a cab ride. But part of that is also the value. People are always, in the physical world, people are always willing to wait longer if the fruits of that wait is larger. Okay, and we wanted to see if that is true with the online world of online videos. So we did the following. We looked at users who are watching short videos like news clips, and we looked at users watching longer videos like movies, and tried to figure out if they were abandoning differently. And it turns out that people who are watching short videos abandon very quickly. Basically, the value of waiting, the value that they were getting from a short news clip is presumably smaller, so they're more impatient. Whereas people are willing to wait longer for movies. So those are all some of the results we have for abandonment. Let me actually talk about the last result, the last relationship that we looked at, which is repeat viewership. This is very important because if you talk to video content providers, they would like people to come back and watch more videos later. They want to build a subscriber base that's loyal. So we asked the following question. Suppose you are a viewer, you go to a website and you watch videos. You try to play the videos it doesn't play, you're frustrated and you go away. This is what we call a failed visit. A failed visit means you go somewhere, you try to play, it doesn't work, and you go away. And we ask the following question: does a failed visit impact the probability that you'll come back again? So what we did was, so here in this plot, you see days on the x-axis here, and you see the probability of return on the y-axis. What we found is that if someone has a failed visit, the probability that they will come back is this bottom line. And for someone without failures, it was the top line. So this clearly says that if you have a failed visit, you're less likely to come back. And this is important to know. We also kind of verified this correlation with a quasi-experiment. We paired up users again. One had a failed visit, and the other user very similar experienced a successful visit. And then we followed them through time and saw what they did, and we scored it. If the failed user came back, we would give it a certain score. If the let's say we would say -1. If the failure-free user comes back, the successful user comes back, we would say +1. If both come back, we would say 0. And if you tally all of those things up, you can actually come up with a statement that basically says a viewer who experienced a failed visit is something like 2.3% less likely to come back to the site within a week than someone who had a successful visit. So to summarize, what we've really shown is that video performance has a causal, quantifiable, and significant impact on viewer behavior. And it's very easy to take these results and translate it into video monetization, because you can basically say, if a user is watching 5% less, they would see 5% less video ads, and so it would impact the revenues in this way, right? Likewise, if a user doesn't come back, then you can say that this will affect your subscriber base in this way. So these things can be linked into video monetization, which is kind of interesting.
I guess you could also see if you show ads, whether people will come back.
Right. So actually, one of the things that we're actually researching, so right now, the focus of this research was just video performance and viewer behavior. One of the things we are actually also researching now is how do ads impact all of this? And that's an interesting question as well. So in the last few minutes, I want to actually switch back into something a little bit different. And I want to talk about something which I call holistic network design. If video performance and performance in general is so important, there is the question of how do you deliver that performance, right? How do you make videos perform better? And the typical answer has been you deliver videos through a large distributed system called a content delivery network, right? In fact, I'm telling the story a little bit backwards because this is the picture that I really started with 12 years ago. 12 years ago, we were trying to build one of the first video delivery systems. And one of the things that I was trying to do is how do you build this big network that can, that can deliver lots and lots of videos with high performance, right? And there really wasn't, I'm really talking about 2000, something like that. There really wasn't much, people really didn't know what video performance meant at that time. And certainly the link between video performance and viewer behavior was not known scientifically at that time. There was just hearsay that rebuffering causes frustration and things like that, but there really wasn't anything scientific like what I've just said. So that's what got me thinking about this whole problem in the first place. Coming from sort of the distributed system design standpoint. And there are a lot of trade-offs that you need to make when building a big content delivery network. For example, one classical trade-off is the trade-off between rebuffering and startup time. You can always buffer more in the network and prevent rebuffers, but the videos will start up later. It's a very standard trade-off. That is one of the things that I spent quite a lot of time racking my brains about on where to make that trade-off. How much buffering should I do versus, because the more you buffer, the less you're going to rebuffer because you have enough in your player buffer to play back, right? Those kind of design questions and trade-offs, or even the question of what aspects of video performance matter, really depends on this relationship between video performance and viewer behavior. And this is what I call the virtuous cycle. So the virtuous cycle of content delivery is basically something like this. So if you're a video content provider, you're trying to monetize your content. So you ask a video content delivery network to deliver your videos. The content delivery network hopefully provides better performance. That better performance hopefully improves viewer behavior, and we've shown that link now. And viewer behavior, very easily leads to better monetization. And as the content provider monetizes the videos more, there might be more investment in better networks. So this is the virtuous cycle, and I believe that for any network, it's important to understand this virtuous cycle. And such virtuous cycles exist for pretty much any network. So here is an application delivery network. So if you go to an Amazon.com or if you go to an e-commerce site, that is delivered by an application delivery network. That virtuous cycle looks like this. You have an online retailer who makes an investment in an application delivery network. That provides better performance. Usually that means more availability of the web pages, more better download times. Hopefully that leads to better shopper behavior. For example, people measure things like bounce rate, which is users coming into an e-commerce store and going away without buying anything, right? Then there's conversion rate. What fraction of the users actually convert and buy? How many come back over and over again? Those are all shopper behavior metrics. And better metrics for shopper behavior lead to more monetization, which could lead to more investments. And so really, the thing that I want to actually end with is to say, network performance, we've been studying network performance in academia in isolation without considering this virtuous cycle. And I believe that any network service has a virtuous cycle. For example, here is a very generic one where you have an online business which makes an investment into a network service, leads to better performance and better user behavior, which leads back into monetization. So my contention is that one needs to study network design and network architecture in a holistic way. Mostly we've been studying network performance in isolation, but really you should study network performance in conjunction with user behavior and in conjunction with monetization. And that leads to not just better monetization, but also better network design. Because we're understanding user behavior, you can actually create networks that are tailored to enhance those behaviors. And this kind of a design wasn't possible even 5 years ago because the data was not there, the techniques were not there. But I feel that in the future, with big data being available about networks and users, and techniques like the QED technique, Quasi-Experimental Design technique that I mentioned, you could actually do network design and network performance design in a holistic way by putting the user back into network design. The user has been missing from network design and network architecture for a while, and you can put the user back and in a systematic way design networks that look at the whole picture as opposed to just a single piece of it. So I will stop here for questions and just say that if you're interested in learning more, that we wrote an IMC paper about quasi-experiments, which you can look at. Some of the other stuff that I talked about, like the virtuous cycle, I wrote a position piece recently, which is this paper here, and you can actually find most of these papers on my URL. Thank you.